Okay, we've been working a little bit on Newton's experimental law of restitution. I'm going to move on from that and talk about collisions between moving particles. And we said in previous lessons that the final velocity instantaneously after impact is equal to negative e times the velocity instantaneously before impact. When we have two particles moving, so for example, and again we're going to be dealing with what we call direct collisions, where we have identical particles moving, along the same line of motion and kind of colliding in that way. Maybe they're moving towards each other, maybe they're moving in the same direction with one catching up. They all are governed by essentially two rules. When we're dealing with two moving particles, we're going to be using relative velocities. Remember, up until this moment, we've been looking at one particle in motion striking against a plane, a wall, or the ground, or something like that. In this lesson, we're going to be looking at two particles in motion, and we're going to be using relative velocities. So, Newton's experimental law of restitution for two particles in motion says that their relative velocity instantaneously after impact is equal to negative v times their relative velocity an instant before impact. Okay, so there's kind of an instantaneous change in velocity here, in relative velocity. So there's going to be two things we're going to be using. We're always going to be using Newton's experimental law, and we're going to be using the principle of conservation of linear momentum here as well. Newton's experimental law says their relative velocity an instant after impact will equal to negative e times their relative velocity an instant before impact, and the principle of conservation of linear momentum says the total momentum before will equal to the total momentum after impact. And again, that's an instant before and an instant after. So we're always going to do the same thing. We're going to start by establishing the initial velocity of A, the initial velocity of B. We're going to establish the mass of A and the mass of B. We're going to find then hopefully the velocity of A and the velocity of B. Some of these things will be left out depending on the question, and our job is to kind of find the missing thing. Okay, so depending on the question, our job is to find the missing thing. So here's a question based around this kind of stuff. This is taken from the 2010 Ordinary Level Leaving Cert exam, and it says a smooth sphere A of mass 2 kilos, that's this one, collides directly with another smooth sphere B of mass 3 kilograms on a smooth horizontal table. Okay, collides directly, we're talking about identical particles moving along the same line. A and B are moving in the same direction with speeds of 5 and 4. The coefficient of restitution for the collision is 2/3. So I'm going to say they're both moving right. I'm going to say this is a right positive. A is moving faster at 5, B is moving slightly slower at 4, but both moving to the right means both of them will have initially positive velocities. So the initial velocity for particle A will be positive 5, and the initial velocity for particle B will be positive 4. The mass for particle A is given at 2, and the mass for particle B is given at 3. We want to find the speeds of A and B after the collision, so I'm going to just make up some variables here. Let's call these X and Y. The other thing we're given here is that the coefficient of restitution is equal to 2/3. Okay, so we're going to use two things all the time. Questions of this type, essentially we use the same kind of process all the time. We're going to start off by using Newton's experimental law of restitution, which is given in your formula and tables booklets. In your mechanics section, you're talking about Newton's experimental law of restitution. It's on page 51. And it says V1 minus V2 is equal to negative E times U1 minus U2. Their relative velocities an instant after impact will equal negative E times their relative velocity before impact. So plugging in here, V1, that's X, V2, Y, negative E is negative 2/3, U1 is 5, U2 is 4, Notice signs are important here. They're both moving in the same direction, so they'll have the same sign. And from that I can come up with an equation. So we're going to have x minus y. 5 minus 4 is 1. That's just negative 2/3. If you want, that third, some people don't like to see that 3 down there, so tripling both sides, 3x minus 3y is equal to negative 2. And I'm just going to call that equation 1, and I'm going to keep it for a moment. And you can probably see where this is going. I'm going to use a second equation. I'm going to develop a second equation here. And the second equation comes from the principle of conservation of linear momentum. Notice I'm giving it a title. I'm always going to write the full thing out. Also on page 51 of your Foreman Tables booklets. M1U1 plus M2U2 is equal to M1V1 plus M2V2. And again, just plugging everything in here. So M1, 2 times U1, 5. 2 times 5. Plus M2, 3 times U2, 4. 3 times 4 is equal to M1, 2 times V1, X. Plus M2, 3 times V1, V2, Y. Okay. Solving there. 2 5s 10, 3 4s 12, altogether that's 22. 22 is equal to 2x plus 3y. There's my equation number 2. And what I'm really liking here is that I have a negative 3y up here and a positive 3y over here. So I'm going to solve these using what's called the elimination process, solving a system of equations using elimination. Equation 1, equation 2, I'm going to rewrite them. Equation 2, maybe I'll write first, 2x plus 3y equals 22. Equation 1, 3x minus 3y equals negative 2. Using the addition property of equations, we're adding this, not changing the sign of anything. So 2x added to 3x, that's 5x. 3y added to negative 3y, 0. 22 minus 2, 20. And from that you can work out that x must equal to 4. Let's have a look at y. What do we know about y? Well, going back to maybe this version of equation 1, x minus y is equal to negative 2/3. We know that. So solving for y there, y is going to equal to x plus 2/3. Which means, given that x is 4, y is going to equal to 4 and 2/3. Okay, going right back up to my question, we're trying to find the speed of A and the speed of B. What have we found? We found x and y, which are their velocities. Notice both are positive, nothing is turned around here. So the velocity of A after impact will be 4 meters per second, and the velocity of B after impact will be 4 2/3 meters per second. And notice those velocities are positive. We don't have to worry about direction too much or sign. The other thing to note, that's just going to equal to the speed of A, and that's going to equal to the speed of B immediately after impact. Okay, so that's what was asked, find the speed of A. I'm going to leave these two out and leave you to solve those yourself. But ultimately that's Newton's experimental law of restitution using and the principle of conservation of linear momentum to solve a problem involving the collision of two moving particles. So I'll do a couple of more videos on those, but get practicing. We're in section 7b in your textbooks, so get practicing in there, 7b, and we'll get through a few of these. So I'll do 2 more videos on different problems involving these types of questions, but they're all answered in pretty much the same way. Okay?